Hello everyone. So today we will discuss atomic structure. In this synopsis, in five part we will cover up. So in first part today we will discuss that discovery of subatomic particles, electron, proton and neutron. And then after we will discuss their atomic model, two atomic model we will discuss, J.J. Thomson and Rutherford. And at last we will discuss particle nature of light, black body radiation and photoelectric effect. So let's start this topic. So before starting this topic, little bit we'll discuss about the genesis, history about that this atomic structure. So we all know that one well-known scientist and philosopher, that Maharshi Kanad, he told that any substance or matter is made up of very small particle, that is called Anu and Pramanu. After that, Democritus also came subsequently, and he also told that the smallest indivisible particle is only fundamental particle of any substance. And this theory was only accepted by Dalton also in his atomic theory, Dalton atomic theory. But as science progresses and time passes, then after one scientist whose name was William Gilbert, so when he was combing his hair, so he felt some sort of attraction between that hair particles and comb. So he thought that both are made up of atoms only. If they are having attraction or interaction, means they having charged particle also inside atom. And parallelly, that one well-known world-renowned scientist, that Michael Faraday, he was also working on that electromagnetic induction theory. So almost that theory was about to come, that atom is not the smallest particle. Inside atom, charged particles are also there, which is the subatomic particle, which is more fundamental and more minute than atom. So in that respect only, that one scientist whose name was William Crook. So William Crook, he curated one that apparatus, in that he took one long glass discharge tube and two metal plate connected respectively with negative and positive terminal of the battery. So negative plate is called cathode rod and positive plate is called anode rod. And in that order only, one another scientist whose name was Julius Plucker, he thought by using this apparatus, if I will prove that air or gaseous particles are conductive in nature, or means they are containing charge, which is very poor conductor of electricity, gases are poor conductor of electricity. If I will establish this point that gaseous particles are containing charge, means henceforth after that all those matter which is made up of atoms also can be considered as that in that charged particles are present. So in that Julius Plucker, that he applied this two condition, that in discharge tube by vacuum pump he decreases the pressure up to 10 to the power minus 4 atm and increases the voltage 10 to the power 4 volt. So due to that, what happened, gaseous particle gets ionized. You can see that hydrogen, oxygen or nitrogen atoms getting ionized, H positive and electron and so on and so forth. This is same like that concept we discuss in kinetic chapter also. In kinetic also we discuss that if any reactant, if it is forming product, it must pass that two factor. First one is that collision factor and second one is that energy factor. Means orientation must be proper and energy must be that minimum energy should have activation energy so that it can form product. So similarly here also you can see by increasing voltage it having sufficient energy, and by decreasing voltage by decreasing pressure that molecules of gas decreases. So if that probability of effective head-on collision increases, and due to that only this ions got ionized, is broke into positive and negative ions. So after that, Julius Plucker, J.J. Thomson came and he got Nobel Prize for the cathode rays experiment. Why? Because he studied many properties of cathode rays, such as cathode rays moving in a straight line. So he kept in that long glass discharge tube one opaque object, and when that invisible rays were passing, it formed very sharp shadow of that object. So whenever that rays due to that object image is sharp shadow is formed, means that rays are moving in a straight line. Otherwise, if it is coming with some angle, so image will be either elongated or a small in size from that real object. So from there it is proved that cathode ray is moving in a straight line. Second, he established that he kept in that thin paddle. So thin paddle started moving as cathode rays traveling. So from there that it came into that picture that cathode rays having mechanical effect, means it having mass as well as momentum. Another property also studied that it can affect photographic plate, it can penetrate thin metal sheet. If suppose this invisible rays are passing, here he applied zinc sulfide coating, so hydrogen gas that electrons as it is passing, so here green fluorescence is created, it having heating effect. So these all those property who studied J.J. Thomson, so that he got Nobel Prize. Also he calculated a specific charge E by m value. So for irrespective of any gases, that you can see E by m value, charge is same and mass of electron also same. So overall a specific charge value 1.76 into 10 to the power 11 is the constant value irrespective of any type of gas. One another also property that he studied, that when he applied electric field, so that all those cathode rays particles, cathode rays deflected towards the positive plate, or magnetic field when he applied, then it deflected towards the north pole. So from there he concluded this all those cathode rays, since it is moving from cathode to anode, is called negative rays. And this negative rays, that name is given by Estoni, another scientist, is called electron. So by this discovery of electron happen or cathode rays happen, here you can see it having charge minus 1.6 into 10 to the power minus 19 coulomb, or minus 4.8 into 10 to the power minus 10 ESU, electrostatic unit in CGS. Mass 9.1 into 10 to the power minus 31 kg, which is almost negligible, because divided by 10 to the power 31, so mass will be almost 0. Or in CGS also, that 0.000548 AMU, atomic mass unit of that one electron. After this discovery of cathode rays, anode rays discovery also happened. But before that, little bit we will discuss about Millikan oil drop experiment. So in Millikan oil drop experiment, he took one container. In that, two plate he connected. One is circular positive plate and one is negative circular plate. Means circular plate upper one is connected to the positive terminal of the voltage source, and negative plate is connected to the negative terminal of the voltage source. So due to that, what happened, that when he sprinkled some oil drops on the positive plate, so positive plate at center it having hole, so all oil drops started coming through that hole at down, and when it is coming down, he pass X-rays. So due to that X-ray source of energy, that oil particles broke into two part, one is positive part and negative part. So let's try to understand that positive part is there. So on positive part, electric field working from positive plate to negative plate downward, and gravitational force also working downward. Means on positive particle, electrical force and gravitational force since working downward, so positive oil drops fell down and came on the negative circular plate. But that negative oil drop, on that electrical field is working, electrical force is working upward in opposite direction, negative to positive side, and gravitational force working downward. So overall at certain voltage, that electron, that negative oil drop became static, and at that static position he equated force, electrical force is equal to gravitational force, QE is equal to mg, and from there he calculated charge on electron, that is minus 1.6 into 10 to the power minus 19 coulomb. By the way, charge on electron or charge on proton having magnitude wise same value, positive and negative is just representing its nature. Now after this we will discuss discovery of anode rays or proton, which is done by E. Goldstein. Actually discovery of anode ray also should happen that moment only when discovery of electron or cathode ray occurs. Here you can see that all those positive particles also ionize that moment. Means when electrons are moving from cathode to anode side, that same moment positive ions also moving from anode to cathode side, but that time it was not discovered. So after some years that discovery of anode ray also came into picture by E. Goldstein. Using that same apparatus, only he changed, instead of cathode, perforated cathode. Perforated cathode means in that many canals there, holes there. Since that already due to cathode ray that long glass discharge tube is bright, so another invisible rays as it is passing from canals, holes, then it can be recognized. So that's why instead of cathode he took perforated cathode. And due to this reason only, anode ray, since it is moving from anode to cathode, is also called canal ray. That anode ray also called canal ray. Now here all again properties are same. It is moving in a straight line, it having mechanical effect, heating effect, it can penetrate thin metal, it having also that it can also create fluorescence on zinc sulfide. But two properties different. One is that when he applied electric field, so it deflected towards the negative plate of the field or south pole of the magnetic field. By that it is clear that anode rays are positive rays. And another one is that a specific charge when he calculated. So charge by mass, you can see charge already everyone having +1 unit. So this having same charge 1.6 into 10 to the power minus 19 coulomb, but mass wise different gases having different mass. So if mass q by m, in that if mass is more, a specific charge will be less. So here minimum mass is for hydrogen, means for hydrogen a specific charge is maximum, and a specific charge depends on the nature of gas. Here we can see proton having charge 1.6 into 10 to the power minus 19 coulomb or plus 4.8 into 10 to the power minus 10 ESU, electrostatic unit. Mass is 1.67 into 10 to the power minus 27 kg. In gram it will be minus 24, and in AMU 1 AMU. After discovery of this cathode rays and anode rays, and that discovery of neutron also happened. So discovery of neutron how came into picture? That after discovery, when they started calculating mass of after discovery of electron and proton, mass was not coming accurately. Like let's suppose for example carbon. So carbon having 6 proton and 6 electron. So 6 proton mass is 6 AMU and 6 electron mass is almost 0. So overall mass is coming theoretically 6, but actually is 12. Then after scientists thought that okay, that charged particle we discuss, some other also fundamental particle is there which is chargeless mass particle. And for that James Chadwick, he did one experiment, nuclear reaction, in that he bombarded alpha particle, alpha rays on the beryllium surface, and due to that one chargeless mass particle is discovered, that is having charge 0 and mass is relatively little bit more than proton, and mass is 1 AMU. This nuclear reaction how to balance? Here you can see it having 4 plus 2 atomic number total 6, this side also 6 plus 0 6. Here mass is 9 plus 4 13, here also 12 plus 1 is 13. So this equation is balanced, and in this nuclear reaction one chargeless mass particle is discovered. Hence from here 3 fundamental particles of atom is discovered. First one is electron, second one is proton, third one is neutron. Many non-fundamental particles also there like meson, antiproton, anti-electron, that we will not study, is not our in syllabus. Mass order, if we'll see, so alpha particle, alpha is represented by helium. Helium is not alpha particle, but it can be represented by helium representation. So alpha particle mass is 4 mu. Then after, neutron mass relatively more than proton, electron mass is relatively less, almost zero. Electron mass is 18 by 32 times less than the mass of proton. Now here that E by m value, so E by m value, in that less the mass, more will be a specific charge value. So electron mass is less, so its a specific charge value is more. Then after, proton, neutron a specific charge value is 0, because Q by m, Q is 0, so its a specific charge value is 0. After discovery of this electron, proton and neutron, that atomic model came into picture, that how electron, proton and neutrons are present inside the atom. So first model was given by J.J. Thomson, and J.J. Thomson model is also called watermelon model or plum pudding model. So watermelon model is what, that watermelon red part is considered as like a positive sphere, and black seeds of watermelons are considered electrons embedded or ejected into it. And he also told atom is neutral, means total proton is equal to total electron. But this model was static. It is the limitation or drawback of rather that Thomson atomic model, how it disregarded it. This model was a static model, since electrons is not moving, but we know that in metals electrons are moving, that's why they are conductive in nature. So in atom, electrons moving, means this is a static model, disregarded. Or another also drawback, that he not consider at all that neutrons also present in his model. So when this one disregarded, then after Rutherford atomic model came. So Rutherford, he did alpha ray scattering experiment, that alpha rays, positive rays, when it is passing through thin metal, so then after he studied what happening. So he, in his experiment, he took gold because its malleability and ductility is very high. So very thin metal, very thin gold foil he took, and on that he passed alpha rays. Then he saw that most of the alpha rays through that gold atom is without deflection, passing in a straight line. Very few alpha rays, when it is coming little bit closer to nucleus, deflected with a small angle. And very few out of 20,000, one alpha ray, when approaching to center, it returned back on its own path. So from there he concluded at center some positive charge mass system is there. Why? Because alpha ray is also positive, that's why repulsion happening in between. So at center some positive charge mass system is there, and almost whole atom is empty, and at last that electron which is rotating is having extra nuclear path. And he also told that electron is attracted by this nucleus, Coulombic force kq1 q2 by r square, and center applying one opposite force, centrifugal force. Both force are equal, that is kq1 q2 divided by r square is equal to mv square by r. But as Maxwell, another one scientist came, and he told that if electron or any charged particle moving in the field of other charged particle, slowly and gradually it will lose its energy, and as it will lose its energy, then this force will be not equal to each other, because you can see kinetic energy is half mv square, so here also mv square. So as its energy, that electron as it is rotating, it will decrease its energy, means kinetic energy as it will decrease, means this value also will decrease. So this force will be not balanced. So overall what will happen? Electron will fall into nucleus, means there is no existence or a structure of atom. So these explanations were not given by Rutherford, what Maxwell theory proposed. After that also arrangement of electron also not discovered, that in each orbit how many electrons could be arranged. atomic spectrum, hydrogen spectrum, this all those also he not discussed. But yes, we will discuss some his applications. That first application is closest approach of alpha. When alpha rays approaching, so when alpha rays approaching at the center, it can reach minimum that nearest to the center, remaining all rays which is deflecting with a small angle is little bit far from the nucleus. So when alpha rays out of 20,000, one ray as it is approaching to the center, it return back on its own path. So that is the minimum approach, that it came that maximum closer to the nucleus of that metal atom. So let's try to understand here that when alpha rays is starting from here at infinity, so kinetic energy, this potential energy is 0, k q1 q2 by r, and initial kinetic energy is half m alpha v alpha square. At point this r naught, from here this distance between this is r naught, at that time repulsion is very high, so at that time alpha particle stopped, means its kinetic energy became, this segment became 0, and potential energy is k q1 is z into e, whatever the atomic number, into proton having same charge as electron, so that's why it is q1 will be ze, and q2 will be that alpha particle, since so it having 2 proton, 2 positive charge, so we'll take 2e. So k q1 q2 divided by r1 naught, instead of that r1 we will take r naught. So from this formula came r naught is equal to 4k ze square divided by m alpha v alpha square. K value in SI unit we will keep 9 into 10 to the power 9, and in CGS, if radius is we are calculating in centimeter, then K value we will keep in 1. Suppose if we are calculating at here at point P, that distance R1, how much? So at distance R1 at point P, its kinetic energy will be not 0. At here kinetic energy became 0, minimum closest approach, but here kinetic energy is not 0. So again we will apply COE, conservation of energy. So initial potential energy is 0, initial kinetic energy is equal to final kinetic energy at point P and divided by potential energy k q1 q2 by distance between them r1. Next, another application is that he also calculated volume of atom. So volume of atom is 10 to the power 15 times more than the volume of nucleus, means volume of nucleus is very small. Third application, that when alpha rays deflected with a small angle, so number of alpha rays we can relate with sine to the power 4 theta by 2, means if alpha rays deflecting with a small angle, so such type of alpha rays number will be more. If it is deflecting with large angle, such type of number of alpha rays will be less. If suppose here we are taking metal and its atomic number is more, means we can say at center ZE value will be more. As ZE value is more, so alpha particle will feel more repulsion, so more deflection also will happen if atomic number of metal is increases. Also he calculated size of nucleus. So size of nucleus R is equal to R naught into A to the power 1 by 3 centimeter. A is the mass number of that metal. So these are the applications of Rutherford. Now we will discuss iso series. So iso means same. So at least here something will be same. Iso series, isotopes means atomic number will be same and physical properties here same, chemical properties will be different. Isobar means chemical properties will be same, physical properties will be different, and atomic mass will be same, atomic number will be different. Isoelectronic, in that number of electrons will be same. Isotones, in that number of neutrons will be same. It is also called isotonic or isoneutronic. Isodiaphers, in that A minus 2Z value will be same, means atomic mass minus 2 into Z atomic number, and isosters in that number of electron and atomicity means number of atoms will be same. So these are the iso series. Now we will discuss electromagnetic radiation. So electromagnetic radiation, sunlight is example of electromagnetic radiation. So in this, that electric field, magnetic field and resultant vector electromagnetic wave are perpendicular to each other. It travels in vacuum, and in medium also it can travel, but without medium also electromagnetic waves can travel. In vacuum, its speed is 3 into 10 to the power 8 meter per second. In other medium, its velocity will be different. Now, since it is wave, whenever that sunlight is moving, so it will be having in form of wave, but whenever it is colliding and falling on any metal surface, then it will have particle nature. So that particle nature we will study today. That wave nature already you have studied in physics, like reflection, refraction, interference also two types of interference, constructive, destructive. A diffraction also you have studied, so that we will not study. Particle nature of wave we will study. So anyway, that any wave, in that you know that wavelength is what? Distance between two constructive crust or trough. That wave that upper part, this is called crust, this is the crust, and down portion is called trough. So distance between two constructive trough or trough, whatever that distance is there, is called wavelength. Wavelength is measured in meter. So relation between meter and angstrom, 1 angstrom is equal to 10 to the power minus 10 meter or 10 to the power minus 8 centimeter. 1 nanometer is equal to 10 to the power minus 9 meter. 1 picometer is equal to 10 to the power minus 12 meter. This one very important. 1 angstrom is equal to 10 to the power 1 nanometer or 10 to the power 2 picometer. Next coming that frequency. So numbers of wave passing through a point in 1 second is called its frequency, and its unit is hertz or cycle per second. Next, velocity. So linear distance traveled by wave in 1 second is called its velocity. Relationship between velocity, frequency and wavelength is velocity is equal to frequency into wavelength. Amplitude of wave. Amplitude is what? Either height of the crust or depth of the trough is called amplitude of any wave. This is nu bar is wave number. So wave number is reciprocal of wavelength, and this is the time period. Time period is reciprocal of frequency. Means their unit, its unit will be per meter, and time period unit will be second per cycle or per hertz. So on behalf of wavelength, electromagnetic radiations are segregated in different categories. Like here you can see, this is cosmic rays. So cosmic rays wavelength is the minimum. After that gamma rays, after that X-rays, then after UV, then after visible region, then after infrared, micro and radio wave. Means as we are moving this side, wavelength is increasing, frequency is decreasing. Like visible region having range of wavelength 4000 angstrom to 8000 or 7500 angstrom. Now we will discuss that particle nature of light. That we discussed that when light is traveling, it will be behaving like a wave, but when it is falling on any surface, that time its behavior will be particle behavior. So first here we will discuss black body radiation. So black body is perfect absorber or perfect emitter of all kinds of wavelength. Black body. So suppose for example at T2 temperature, if its intensity is this, means at high temperature its brightness is more, and at low temperature its brightness is less. So if at high temperature, if intensity is more or brightness is more, so you can see its wavelength its radiation of wavelength is relatively less. Why? Because energy is more, intensity is more. Here you can see its wavelength is less since its intensity or energy is less, so wavelength is more. So energy and wavelength are inversely proportional. Like here you can see that intensity and temperature directly proportional. Intensity is directly proportional to the T to the power 4. During heating of iron, we know that it will be from black to red, red to orange, orange to blue, and further it will be white if we are increasing throughout temperature. Means we are increasing the energy. Means we are decreasing the wavelength. You can see as we are moving this side, according to Vibgyor concept, here wavelength is decreasing. So that only that by increasing temperature or energy, intensity or brightness will be more and wavelength subsequently will decrease. So this is the black body radiation, which is perfect absorber or perfect emitter. Now after this, before discussing that photoelectric effect, little bit we will discuss about that quantum nature of light or quantum nature of any substance. That remember that any substance will not absorb or emit energy at sudden, and it will emit all its energy at one time only. Either it will absorb or emit in bit by bit form, that is a small packet of energy, and that is only called quantum. In plural it is called quanta. So energy is equal to, that energy of photon is equal to nh nu or nhc by lambda. N is 1, 2, 3, it is integer, means here photons are quantized, it will be not fractional. H value, this is the Planck's constant, so 6.6 into 10 to the power minus 34 joule into second, or 6.6 into 10 to the power minus 27 erg into second. C is the speed of light in vacuum, 3 into 10 to the power 8 meter per second, and n value is integer. Hence this is the you can see that energy is absorb or emit in term of quantum nh nu or nhc by lambda. Energy since proportional to frequency, so energy is additive property. To energy we can add on E1 plus E2. Similarly frequency also we can add on nu1 plus nu2. But lambda wavelength is not additive property. Like wavelength if we are adding, so it will be like resultant wavelength is equal to 1 by lambda 1 plus 1 by lambda 2. So you can see it's direct addition not happening, so it is not additive property. In questions also, that photoelectric effect, in that questions also this one type of questions will come, that bulb questions. So bulb, as it is emitting light, so it's, let's suppose 100-watt bulb. So watt means what? 100 joule per second it is giving energy. In some question they will utilize efficiency of bulb also. Let's suppose 100-watt bulb having efficiency 80%. What is meaning of that 80%? Its meaning is that 80% energy of photons coming in form of wave, and 20% is still is converting in form of heat. Next, here for solving questions, this is the shortcut. No need to put always that value of h and c. After putting h and c, we will get that ready-made formula. E is equal to n12400 divided by lambda, must be in angstrom, then energy will come in electron volt. Or if lambda is nanometer, then here we will keep 1240. If suppose in any question energy is given of that energy of photon, if it is given in joule, then here since this is electron volt, so here also you can convert in joule by multiplying 1.6 into 10 to the power minus 19. If energy in question of photon, if it is given that in kilojoule per mole, then here you can convert electron volt into kilojoule by multiplying 96. If energy of photon is given in kilocalorie per mole, then this side you can multiply by 23, then you can equate and you can calculate number of photons or wavelength whatsoever it is asking. Now one small topic we will discuss, 1 electron volt, that when electron is accelerated in 1 volt potential difference, what happens? So we all know that negative charged particles moves from low potential to high potential, and positive charged particle always moves from high potential to low potential. So here that one voltage potential difference is created, electron moving from low potential to high potential. By applying conservation of energy, initial potential energy is 0, kinetic energy also 0. Final potential energy is Q into V, so minus E into V, and this is the kinetic energy. So final kinetic energy is equal to E into V. So Coulomb into volt is Joule. So kinetic energy of that electron which accelerated through 1 volt, its 1 electron volt kinetic energy value is equal to 1.6 into 10 to the power minus 19, that is the Q value or electron value, into 1 volt. So Coulomb into volt is Joule. So 1 electron volt kinetic energy of that electron is equal to 1.6 into 10 to the power minus 19 Joule, or it is 96 kilojoule per mole or 23 kilocalorie per mole. Here one another thing also we can see, that kinetic energy is equal to Q into V. So this V is voltage and kinetic energy is half mv square. So this is the velocity of charged particle is under root 2Q into V. V is the voltage divided by mass. So we can compare two charged particle velocity if voltage is known to us, clear, and its amount of charge. Moving further, now we will discuss photoelectric effect. So photoelectric effect is also particle phenomena, since that whenever that photons is moving, it will move like a wave, but when it is colliding, falling on any surface, then it will behave like a particle. That one photon will emit only one electron, means it is behaving like a particle. So photoelectric effect, in that most suitable metal is cesium. Generally alkali and alkaline earth metal is taken, but in that most suitable is cesium. This postulate we need to keep in our mind. There is no time lag between a striking of photons and ejection of electron. As soon as photoelectrons are falling on metal surface, from that valence electron is coming out. One photon emits only one electron. This is only its particle nature. So that any metal will have valence electron, and that valence electron is attracted by kernel, that nucleus of that metal. So that minimum energy is required so that electrons come out from the metal surface. That minimum energy is called work function. So if energy of photon which is falling, if energy of photon is less than the work function, then electron cannot come out from the surface, means no photoelectric effect. No photoelectric effect. But if suppose energy of photon, if energy of photon is greater or equal to the work function, then what will happen? Then photoelectric effect will happen, means electron will come out from the surface, and whatever the extra energy is there after work function, that remaining energy of photon is only called kinetic energy, means movement of that electron. And when that movement of electron will happen, then photocurrent is generated in photocell. Work function is also we can consider as its ionization energy of that metal. So that any certain metal, for that minimum energy is given so that its electron come out. So for that minimum energy threshold frequency, here you can see this E is equal to h nu naught. So this nu naught is called threshold frequency, a critical frequency. So since minimum energy means threshold frequency value also will be minimum, but wavelength is inversely proportional, so threshold wavelength value will be maximum. So with respect to this, if suppose that sunlight or that energy of photon, if its frequency is greater than, nu naught. If its frequency is less than nu naught, then of course no photoelectric effect. But if frequency of photon is greater than the nu naught or equal also, then photoelectric effect will occur. And opposite of that we will apply for wavelength. If suppose wavelength is less than the lambda naught, so if wavelength is less, means energy of photon is more. So energy of photon is more, then photoelectric effect will happen. If energy of photon's wavelength is greater than the lambda naught, then energy of photon is less than the work function, then no photoelectric effect. So we discussed that for any photon, its frequency is fixed. So if frequency is fixed, so remaining energy is called kinetic energy, and that kinetic energy will be maximum. Why? Because for metal, work function is also fixed. Energy of photon also, if we are taking any photon, means its frequency is also fixed. So kinetic energy value will be maximum, that is energy of photon h nu minus h nu naught, or hc by lambda minus hc by lambda naught. Means kinetic energy of photoelectron, which we calculated here, either it will be 0 or it will be maximum. So it is the range of that photoelectron's kinetic energy. Now here we can see that kinetic energy versus frequency. If frequency increases, frequency of photon which is falling on metal surface, means if energy of photon is more, work function is constant, means kinetic energy also will be more. So this is y is equal to mx plus c. So mx plus c, in that you can see c is the negative intercept. So this is h nu naught, and this is the straight line. So this is the slope, tan theta is equal to h. So irrespective of any metal, slope will be constant. And by increasing frequency, kinetic energy of photoelectron also can be increased. Now we will discuss intensity. So intensity means what? Brightness. So more the number of photons falling per unit area per unit time, you can see number of photons falling per unit area per unit time is called intensity. So for any photons, intensity means brightness is not proportional to frequency, because for that photon frequency will be constant. Means intensity only depends on number of photons. More the number of photons, more will be brightness. If one photon, if we are considering, means just by saying it's that photon, its frequency is constant. Now only we can fluctuate number of photons. So more the photons, that photon's intensity will be more. Now here we will discuss some graphs related to this topic. It's very important. In physics also you have studied, it will help you a lot. So let's see first that kinetic energy versus intensity. So as here you can see intensity is increasing, means number of photons are increasing. So as number of photons are increasing, so due to that intensity will increase, but kinetic energy will not increase. Why? Because for each photon, kinetic energy is what? H nu minus H nu naught. So for each photon, H nu is already fixed, and H nu naught is also fixed. So kinetic energy also will be fixed with respect to even number of photons we are increasing. For each photon, kinetic energy value will be maximum. Next we can see that kinetic energy versus frequency. So till threshold frequency, here H nu naught, so kinetic energy will be 0, and after that kinetic energy it will increase linearly. Next coming that when electrons are moving, so in photocell photocurrent will pass. In photocell photocurrent will pass. So when that photocell, when that photons are falling on that metal, so number of electrons are coming out. So here you can see current is equal to Q by T, charge by time. So number of electron divided by time. So as number of electrons increases slowly, from the metal surface as photons are falling. So number of photons as falling, so number of electrons also increasing per unit time. So photocurrent increasing. But one time will come for that certain frequency of that light which is falling. Due to that, what happened? uh, at one point, number of charge per unit time will become constant. Let's suppose at t1 time 3 electrons emitted. At t1 time 3 electrons emitted. So charge per unit time how much? 3 electron in per second. Slowly after that, what happened? As we are increasing that, here n means number of photons. As number of photons, its frequency is fixed, means kinetic energy will be constant, but as we are increasing its number of photons, so due to that number of electrons also emitted more. But as number of intensity, as number of photons falling and its value is increasing, so number of electrons also from metal surface per unit time increasing. But one time will come for that, what will be that from that metal, that number of electron per unit time will be constant, even we will increase intensity whatsoever. So we can see that current is called saturation current, means now current is becoming constant. So when that photocell from cathode, on that cathode, when electron, that energy of photons is falling, so when that electrons are coming out, so to give that one proper direction, that minimum voltage is applies to cathode and anode. That minimum voltage is, you can see here. Due to that minimum voltage, now all those ejected photoelectrons from cathode moving towards the anode and photocurrent is generated. So here that n increasing means what? Intensity we are increasing, intensity of that photons which is falling, means number of photons we are increasing, frequency we are not increasing. So due to that number of electrons, because per photon will increase per electron, so number of electron also increases. But metal having one capacity, from metal surface how many electrons maximum can emit. After that current became constant, and that is the saturation current. So at saturation current, you can see current is constant. So here IP, as it is constant, even frequency also we are increasing, because for that metal surface it having capacity that maximum electron per second how much can emit. So even we will increase n also, or even we will increase frequency also, after some period of time current become constant. Saturation current is independent from the frequency of photons which is falling on metal surface. Now after that we will discuss a stopping potential. So what is the stopping potential? When that photoelectrons moving from that, after emission, when it is moving from cathode to anode, so for that minimum voltage we applied. Due to that, what happening? It having one proper direction and moving from cathode to anode. If we will change the polarity of that, so due to that, what will happen? Cathode will become now positive, anode will become now negative. So due to that, when electron is coming and about to touch that cathode, but due to that now polarity is changed, now it will have sort of repulsion. So about to touch, but now it will return back and it will go to, so before that it was moving from cathode to anode. Now it is about to touch anode, but it will return back. Why? Because we changed the polarity. Anode became negative and cathode became positive. So that minimum voltage is only called a stopping potential. So you can see here, this is the V minimum, and its same minimum value, by changing its polarity, this became a stopping potential. So a stopping potential is the negative value by which, when electron, as it is moving from cathode to anode, but as we change the polarity at that same minimum value, so due to that anode became negative, so it is about to touch, but now it will return back. So extra plotted we did here, extrapolation, and this value is only called a stopping potential. Means that electron which is flowing now, that electron now retarded, and slowly that current will be at that time will be 0 IP current, because almost we are trying to stop the electron by reversing the voltage. So now further moving here, that last two graph we will discuss, that intensity as we are decreasing. So as intensity we are decreasing, number of photons also we are. So here as what we are doing, intensity we are decreasing. So by decreasing intensity, what we are decreasing, number of photons we are decreasing. As number of photons we are decreasing, so due to that what happening, number of photons as decreasing. So here as we discussed that IP is equal to photocurrent is equal to N into E, number of electrons per unit time. So as here we are decreasing intensity, means number of photons we are decreasing which having same frequency, so that each photon eject each electron. So as here photon we are decreasing, so number of ejection electron per unit time also decreases. So due to that what will happen, IP current also decreases, you can see here. So as intensity decreases, IP value decreases. IP value decreases. Like here let's suppose 3 electron emitted, and after that 5 electron per unit time became constant. At high intensity 3 electron, 5 and 7 electron per unit time became constant. So IP current decreases by decreasing intensity, keeping frequency constant. Since frequency is constant, kinetic energy will be constant, and kinetic energy is equal to Q into V, means E into a stopping potential. So if kinetic energy is constant, means a stopping potential also of that metal will be constant. Just by decreasing that intensity, photo current will decrease. Now here we will discuss that energy of photon h nu is equal to h nu naught plus kinetic energy. Kinetic energy is E into V. So E into that minimum voltage, negative voltage, that is a stopping potential. So a stopping potential is equal to h nu by E minus h nu naught by E. So if we'll relate this, y is equal to mx plus c, so intercept is negative, that is h nu naught by E. So here you can see h nu naught by E, this is the negative intercept, correct? And slope is E by h by E. So for each metal slope is constant, irrespective of any metal, tan theta is constant. And this is y is equal to mx plus c graph. Clear? Now moving further, we will discuss one question. Let's suppose that in this question is given that when light of frequency 2 nu naught falls on the metal, that a stopping potential is found to be V. What would be new stopping potential if frequency of light is 4 nu naught? So energy of photon is equal to work function plus kinetic energy. So 2h nu naught, as it is given here, 2 nu naught is equal to work function h nu naught into Q into V, E into Vs. So a stopping potential is coming h V naught by E. According to question, if it is frequency is increased 4 nu naught, so it will be 4h nu naught is equal to work function h nu naught, and let's suppose this stopping potential E V dash S. So a stopping potential V dash will be 3h nu naught by E, means we can see a stopping potential increase by 3 times. Oh, means for energy of photon, if frequency of that photon if will increase, then subsequently what will happen, kinetic energy will increase, and what will increase, a stopping potential also will increase. So for certain metal, work function remains constant. By increasing that energy of photon, that kinetic energy also increases, and subsequently a stopping potential also increases. Clear? Next, moving further, next we will discuss bond energy and kinetic energy. So suppose that one atom is there, A, and in between this bond is there, and on that sunlight is falling. So if energy of photon is less than its bond energy, then bond will not break. If energy of photon is equal to the bond energy, then bond will break, but this atoms will not move. But if energy of photon is greater than the bond energy, then bond will break also, and kinetic energy also will come to molecules. Percentage of that kinetic energy also we can calculate. So total energy is how much? Energy of photon. In that minimum energy, how much is used? Like work function, bond energy divided by total energy, energy of photon into 100. So here you can see one question, that in this question what it is saying, that bond energy of substance is given 384 kilojoule per mole, and calculate the wavelength of photons required to break the bond. So bond energy is given. So bond energy is given in kilojoule. So here we'll multiply by 96. So lambda which is coming, this lambda will be maximum of that photon. Correct? Means energy will be that minimum by which what happen, bond energy is equal to energy of photon. Just breaking. In question it is telling required to break the bond. Now, next part of this question, if wavelength of photon is, if energy of that photon, its wavelength is 2480 angstrom, then calculate percentage energy which converted into kinetic energy. So if wavelength of photon which is falling on that bond, how much? 5 electron volt. Converting into kilojoule, it is 480. So percentage, that kinetic energy how much? So total energy of photon is 480 minus bond energy in previous 384. You can see here 384 this one. So 384 is the bond energy, and divided by total 480 into 100. So total how much is coming? 20%. Means 20% converted into kinetic energy, which is giving velocity to that atoms. 80% utilized for breaking the bond. So here first part we completed, where we discuss discovery of cathode rays, then after Millikan oil drop experiment, after that discovery of proton, then after discovery of nucleus, neutron, and then after J.J. Thomson atomic model, then after Rutherford atomic model. After that we discuss electromagnetic radiation, ISO series also we discuss. Then after particle natures of light we discuss, that is black body radiation, quantum theory and photoelectric effect. And after that we discuss intensity, related all graphs, and then after related some questions. So in part 2 further we will continue. Thank you very much.